Hey everybody, this is Larry. This is day 12 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Yeah, I usually solve these live, so it's a little bit slow. Fast forward to exit, watch another video, whatever you need to do. Today's problem is beautiful arrangement 2. Okay, given 2 entities, you need to construct a list which contains, okay. Wait, what is K? K distinct answers for the differences between adjacent elements. Okay. Huh. This is a really weird problem in general. So I'm looking at the thing is 10 to the 4th, so it's 10,000. So something n squared is not going to be enough. So this is going to be I don't have an immediate answer. I know that very often it seems like I do, but my intuition is that it's going to be a constructive algorithm that's probably linear time, maybe n log n time, for it to be fast enough. I think without loss of generality, we can probably start at 1, and then we can construct them in. My question is whether I can construct them in a greedy way. Let's play around a little bit. Given that, n, we have k goes from 1 to n minus 1. So, yeah, so there are really only 2 cases for n is equal to 3, right? So what I like to do is that I like to construct, for the smaller cases, what the answer would like as well, just to kind of see how I feel, see if I could feel anything about it. And sometimes I would, maybe not this one, maybe I would, I don't know, we'll see. But sometimes I would run like a brute force algorithm if it's able to for small n, so that you could kind of see the pattern as well. But here, I think we can see, maybe quickly, because I have some intuition now that I think about it a little bit. So k equals to 1, so 2, let's say we still start with 1, then we can have just 2, 4. In this case, there's going to be 2. This is going to be 2. This is going to be 1. This is going to be 2. But it's a little bit awkward, so that might not be the answer that we give. So answer is 3. Then it's 1, 4, 3, 2. No, that's not right. That's 3. That's 1, and then that's 1. So we'll actually want something like this. But I don't know that this is the best. Is this a little bit better? Because then now this is 2, and this is 1, this is 2. I think this is probably the way to do it. And yeah, and if I have any doubts, I would try again for bigger numbers. For k equals to 1, it's pretty straightforward. But k is equal to 2, you can see that. So then now we can, see the pattern a little bit and try to build the intuition and to prove itself. So what I'm doing live is what I would do in a contest. So yeah. The thing to notice is that for the biggest number, these are going to be 1s. So what does this mean, right? This is let me double check this, I guess, for one more. We might as well. We're almost there. Because this doesn't feel right, because this is 4, 3, but then there's no 2, right? So that's not quite enough, even though our intuition is quite almost there, because we need a delta of 2, right? So this would give us the delta of 2. But what is the pattern here then, right? The pattern here is going to be, I think, a little bit of a sneaky reverse-y problem, but it's hard to kind of input. It's one thing to implement it, and then it's one thing to kind of do it that way. But I think another pattern to note is that here, all the difference, you could put everything as 1. Here you have 1 and 2. Here you have 1, 2, and 3. And here we have 1, 2, and 3, and 4 is all the deltas. So we can kind of figure out how to do it in a way, and see if we can figure out a consistent greedy solution. Because, for example, let's say let's say we do a 1 first, and then we do a 2, and then we do a 3, and then a 5. 4, that doesn't really make sense, obviously, because we're missing a 3. So how do we kind of consistently do it this way, right? And I have an idea, but we would have to kind of figure out how to prove it. I mean, my intuition is that when you move a number around from this here, every time you move a bigger number, you create an inversion. Well, the two numbers that you swap is going to still have the same same delta, so same difference that you're arranging, and then but then the one that gets swapped forward will have a different number, right? You do this and it's the same here, of course, and then here it's a little bit awkward. I think going from 3 to 4 is the tricky one for me. But maybe not. Maybe we just have to do this backwards. I think now that I look at it backwards, it makes sense, in a convergence kind of way, because this is 1 plus 4 minus 3 plus 2 minus 1 will be a sequence. So then let's see if we can apply this here, where 1 plus 3 minus 2 plus 1, and then we have a 5, which is, I guess by definition, is that true that it is by definition clear? Maybe, because I don't know if I believe that. So proofs are really hard, as you know. So yeah, let's see. 1, 3, 2, 4, 5 is also a good answer. So so I think for now, what I'm going to do is that, okay, now we have a hypothesis, and it's really easy to check whether, once you generate a function, whether that's the answer. And in lieu of a proof, because I don't have a proof, because these proofs are hard for me anyway. If you're better about it, let me know. But yeah, but now we can, let me try writing this solution and then writing a checker for it so that we can kind of, play around with that idea. Okay, so then now let's say, we have an answer array is equal to, let's just start with here. Well, let's start with 1, and then for k, for delta is in, as we said, we have k starting from k going to 1, and then -1. So then we have answer.append, the last element plus delta, kind of. We have to kind of swap the order of the operation. How do I want to do it? Let's just do sign is equal to 1. So then we just do sign times this, and then we do this, right? And then now we should have the answer, except for this is not enough. While length of ants is less than n, we just append the length of ants. Maybe this is off by 1, but it should be roughly roughly right. Maybe I'm going really fast because I'm explaining at the same time. So yeah, let's also generate a few cases, of course. 3, 1 is one of them. 6 or less, 5, 4, 6, 3. But I was saying earlier, one thing is that you look at these solutions and it's, well, this one is actually much clearer that it is wrong. And it seems like that this should be +1 then. Like I said, I knew that sometimes I don't have, maybe it's not advisable, but sometimes I do things where I know where the potential off by 1s is. So I make a mental note so that I know that, because I know where the risks are. But oh, is it -1? Maybe it's -1. Because the length will be maybe this is just wrong then. Let's just do this right now. 1, 3. So it should, that makes sense. So I think I was thinking about a similar problem, but it's not quite that. But you can see that the prefix is right, so we just have to put out the suffix, even though this expected ends to kind of give it away a little bit. But yeah, so then now we just have to, we just get the smallest number that's not in the set. Yeah, that's, and you can implement this in a number of ways, of course. So scene is equal to, and this is probably a little bit hacky. I don't know what people's solutions are. Like I am doing this live. So yeah, while count is in length of I think this is okay. While count is in scene, we increment, and then we append scene. We append count, and also we add count, right? So this should be okay. I think I was just a little bit lazy. I was thinking about something else, maybe in a weird way. So this looks good right now. I mean, so during a contest or maybe even an interview, you don't have to expect an answer. So this is kind of cheating for sure, especially for these kind of problems. But well, let's get one more cheating first before I will say what I would do in a contest, just so to kind of give me a little bit of confidence. So this actually gives you a lot of confidence knowing that this is kind of correct. But then now, like I said, during a contest, you're going to, during a contest, you don't, I mean, maybe you can YOLO a little bit, but maybe on an interview, you should not YOLO. And then one thing that I would recommend is saying and doing that I would write something to test, which is that, okay. So then now, we can write a checker for answer, which is very quickly, which is that, okay, deltas is equal to set, say, and basically now you'll be writing the verifier for whatever your code is doing, right? And this is just making sure that this condition is true. So yeah, so deltas for x, y in zip of delta. Oops, no, not the answer prefix. Or these look at two adjacent numbers. So yeah, so this adds absolute of x minus y, and then we assert that the length of deltas is equal to k, and we also want to make sure that there are a couple of things we want to assert. We want to think about it, which is that we want to assert that the set of answers is equal to n. That means that the number of distinct answers are equals to n, and the min of answer is 1, and the max of answer is equal to n, right? So yeah. If I was wrong here, for example, if I had an off by 1, like let's say here, sometimes I write the verification code first as well, but you'll see that I have an assertion error because the max number. Maybe I would print a little bit more of a debugging error as well. But you can see that if because the answer that we're giving them no longer holds true for the condition. So that's when we know that we can. This is a good answer because you don't have to have the best answer. You just need to know one answer, right? So then now we can check, even random numbers and have confidence about it. These are pretty much random. I'm just banging on the keyboard right now. And this may actually print way too much, to be honest. But not having an assertion error makes us confident that this is the right answer. For now, I'm going to comment this out, but you can kind of see what I did here as well during a contest to make that confidence. Because if this gives us and of course you should try some edge cases as well, like maybe add in some ones or full amount or something like that. But now I have confidence, and I'm skipping a little bit ahead for the video because this is running a little bit long. But this is my code. Let's give it a submit. And this looks good. But yeah, so you can say that I proved by checking everything. And there's another trick that you can do that in Leetcode it's a little bit harder to do. But for example, if you're doing it, locally or something like that, then you could actually run a for loop to brute force every possible input for n and k. Because here, maybe not every possible, but every reasonable possible input for n and k. Combined with this checker, that will give you confidence that you're having the right answer for every possible test case. And in this case, it's 10 to the 4th square, which is a lot of numbers to do live, as in if you submit it, it's going to be too slow. But on a local machine, that'll be fast enough to test every possible input. And that may be something that I would do as well. And that would be how you would do a unit testing too, because these are literally all possible inputs to the function. So your unit test will be just that, making sure that it's right, something that's valuable on the problem. Let's go with complexity now. yeah, you saw how I solved this problem. You know, it is kind of a little bit tricky for sure. You know, I just kind of try to play around with a couple of patterns and just try to figure out the answer. I don't know if there's anything magical. Let me know how you did it, and there are also there are possibly multiple answers as well. For example, I mean, one easy opposite answer is just inversing this, right? Like you start with 3 and then you go to 1 and 2 or something like that. So that's another possible answer for obvious reasons. And your check will still it'll still pass that check. So your check will be the same, even though your code may be a little bit weird. Okay, so let's go over the complexity real quick. So this loop is clearly going to be k, O of k, oops, which is O of n in the worst case, I suppose, depending on how you want to call that. Here, this is also O of n because, I mean, this is an O of, you could say this is n minus k if you want to be precise, but it's going to be dominated by n. So let's just say this is O of n, at least combined, they're going to be O of n, or O of n. No, I mean, n is strictly bigger than k, so let's just say these two while loops will be O of n, O of n each. Here these two while loops may look weird and may look quadratic, but you can also know that we're only checking each number. You know, this count only goes from 1 to n, so it's almost like a 2 pointers algorithm. You can think of it that way. So because of the 2 pointers, and they're both only they independently, even though they look like they're nested loop, they actually move independently to at most n times, and therefore this is going to be O of n as well in total. And I do know that obviously this in thing, which uses a set lookup, which depending on implementation could be log n or whatever. But let's just say for now, for the sake of argument, that we use a hash table that's O of 1. And yeah, so these combines to be O of n, and that's pretty much it. For space, we have a lookup hash table, and we have the return array, which we cannot make any shorter. So it's going to be linear time, linear space is the answer. And also same thing for here, even though I'm not going to go over that much for the checker. Cool. Let me know how you solved it. There are possibly other ways, there are possibly other algorithms. But I wanted to be very full on how I solved this one. This is a very tricky one because, even if you have a sense of doing it, you have to prove it. And for me, my proof is having every possible input and writing a tester. Proof by exhaustion, I guess, or enumeration maybe is a better word. So yeah, let me know what you think. That's all I have. Hit the like button, hit the subscribe button, join me on Discord. Hope you have a great week coming up. This is Monday, and I'll see you next problem. And to good mental health, bye bye.